Welcome to lesson 5.5. We are going to talk about empirical formulas and how to determine them. Um, if you'll remember in the last lesson, we talked about percent composition. Well, here is one way that is important, is we can take that percent composition and figure out the empirical formula of a compound. Um, so, like it says here, scientists can use percent composition by mass to figure out what the empirical formula is. Formula. And I know you're asking, like, why would they want to do this? Well, the reason that they would do this is because, let's say they're, working for a crime lab and you find this compound sitting around. You don't know what it is. Well, you can determine each of the parts and how much. So you have this sample and you test it and figure out it's whatever, how much carbon, how much hydrogen, how much oxygen. You figure all that out. Then you can calculate what it is based on what's in it. So this is just a way to calculate what something is based on what's in it. So this is how that process goes. First, the sample of the compound is weighed and then decomposed. So you weigh it and then break it down into all its parts. Then each element mass is found. So you break down all the parts, weigh them, figure out the percent composition, right? That's just what we did with the acetic acid. So you find that percent composition, then you can use that to calculate the empirical formula. And we will learn next lesson how to then convert that to the molecular formula so you know exactly what it is. All right, so the best way to do this is an example. Okay? So we found this compound. We don't know what it is. First thing we do is we weigh it. The total mass is 50 grams. That's our first step. Okay. After the compound is decomposed, so break it down and we figure out that 41.33 grams of it is carbon, 8.67 grams of it is hydrogen. That's all that's in it. It's got carbon, it's got hydrogen. Okay. Let's figure out what it is. Okay. So the first thing we do is calculate the number of moles of each element. This is what you learned in lesson 5.3. We know grams, we have to get to moles. Okay, so from our 41.33 grams of carbon, we look on the periodic table and we see that it is 12 grams per mole. We pull out this handy dandy sheet here. I know the mass. I want to get to moles, so I divide by the molar mass from my periodic table. So divided by 12 from the periodic table. When I do that, I get 3.44 moles of carbon. Okay. Then let's do the same thing with the hydrogen. Add 8.67 grams of hydrogen. Divide that by 1 from the periodic table. This one's easy. I don't even need a calculator. 8.67 moles of hydrogen. Excuse me. So that's how many moles I have of each of those. First step, pretty easy. Second step, a little more complicated, but not too bad. It says, find the smallest whole number ratio of atoms by dividing both mole values by the smallest one. So I'm going to divide both 3.44 and 8.67 by the smallest one. Which one of these is smallest? 3.44. Okay? So I do that twice. So 3.44 divided by 3.44 equals 1. Easy. Let's do hydrogen. 8.67 divided by 3.44 equals 2.5-ish. Okay, so 2.5 and 1. Remember, this was carbon. I'm going to jot this down so we don't forget. This is hydrogen. Okay. So we have a little bit more work to do because it says to find the smallest whole number ratio. Is this a whole number? No, it's a decimal, not a whole number. So what we have to do is find the smallest whole number ratio, which means, how do I get this to a whole number? I'm going to have to multiply it by something. Right? The easiest thing to multiply it is by 2. So you multiply that by 2, that gives me 5. 5 is a whole number. And just like in math, I did something to this part, I've got to do the same thing to this part to keep my ratio, right? So I also have to multiply this times 2, which is 2. So the smallest whole number ratio between these two is 2 to 5. 2 moles of carbon, 5 moles of hydrogen. So that becomes my empirical formula, C2H5. Okay. So 2 steps in the process. 1, find moles. 2, divide by the smallest number to find the ratio. So we're calculating the number of moles in step 1, and we're finding the smallest whole number ratio in step 2. Divide, and then make it a whole number by multiplying by something, right? So now we have our empirical formula for our mystery compound. In the next lesson, we'll talk about how to convert that to the molecular formula so we know exactly what we have.